All right, Chapter 6, Section 4, Part 2. Still solving polynomial equations. We did the cubes, now we're going to move on to complex polynomial equations. Solve each equation. Notice here I have x to the power of 4, and I want to solve this equation. All right, so I notice, I don't know if you notice, but I notice that I don't have a 0 on the right. And if I'm going to use factoring and ZPP, I have to have a 0 on the right side. So I'm going to bring that 100 over to the other side. Negative 2x to the power of 4 plus 46x squared plus 100 equals 0. And as I'm doing that, I notice that all of those numbers are even. So there's a GCF. And remember, if the leader of the pack is negative, you want to factor out the negative. So I'm going to take out a negative 2. And I'm going to be left with here x to the power of 4. Subtract, right? Positive divided by negative is negative. 46 cut in half is 23. X squared. And then 100 cut in half is 50. It's got to be negative. And now, this is one of those factoring problems that we saw in the last lesson. Like, it's not quadratic, but it's quadratic in form, right? X to the power of 4. X to the power of 4 is a square, right? Any even exponent is a square. And so I'm going to try to see if this factors. Numbers that multiply to 50 that subtract to 23, well, that would be 25 and 2. Remember, you have to keep this 2 here. And remember, this could be x squared times x squared to give me x to the power of 4. That's the only thing different. It factors the same, just like a quadratic. And we said, what? 25 times 2 is 50, and when I subtract 25 and 2, I get 23. So it's 2 and 25. The signs are different. Larger product, definitely 25. Bigger than this. And so now I can factor this further. Look. This is dots. Difference of 2 squares. So I got negative 2, x squared plus 2, times x plus 5, times x minus 5. Equals 0. Folks, you can't drop these off. Like, it's part of the final answer. You know, x plus 5 times x minus 5 does not equal this, what we started with. So you have to bring it down each step of the way. All right, ZPP. Negative 2 equals 0. Never. X squared plus 2. All right, I can solve that. X plus 5. I can solve that. X minus 5. I can also solve that to equal 0. All right, I'm going to move the 2 over. X squared equals negative 2. Take the square root. X equals positive negative square root of negative 2. Take the I out. X equals plus or minus I root 2. This here, easy, negative 5. This here, easy, positive 5. Okay, so my 2 real and 2 imaginary solutions are x is negative 5, positive 5, negative I root 2, and positive I root 2. Okay, if you have any questions, post in the homework discussion, ask in class, or come to a Google Meet. All right, the next one. Remember, you always first look for a GCF. Why don't you pause the video and try to do this one on your own? All right, hopefully you did try to do this problem. If we look up here, we take a GCF out, and you're left with this, x squared minus 6x plus 6. And then you try to factor this. And you're like, what's numbers multiply to 6 that when I add them, give me a 6? That doesn't factor. So take this part and complete the square. Move the constant 6 over, it becomes negative. Take half of negative 6, negative 3 squared is 9. That's what you add to both sides. On the left side, this is a perfect square trinomial. It factors into one single binomial squared. Negative 6 plus 9 is 3. Take the square root of each side. I get x minus 3 equals positive negative square root of 3. Add the 3. I get x equals 3 plus or minus root 3. Now I have to write my solution. You can't forget about this one. right? ZPP says x equals 0, right? This is one of the factors, which was this factor. That was the GCF. Okay, you can't forget about that one. So here I have a real solution. And these are real as well. X equals 3 minus root 3, and x equals 3 plus root 3. So 3 total solutions there with that problem. Hopefully you were able to figure out that at least take a GCF out and then notice that it didn't factor. And hopefully it came to you that, I have to complete the square. All right, let's look at side 2. 2 more problems on there. I think I'll do number 3 with you, and then I'll pause the video again, and you could try number 4 on your own. So example 3. Got x to the power of 4 minus 81 equals 0. Now, hopefully when you're looking at that, you could see immediately what kind of factoring this is. I'm hoping that you see dots, right? Because any even power on x is a square, and 81 is a square. This is dots, difference of 2 squares. That always factors as a plus b times a minus b. Where you take the square root to get the a, that's x squared, and you take the square root to get the b. So this is x squared plus 9 times x squared minus 9. But we're not done. X squared plus 9, I can't factor that. That's sum of 2 squares, but this is dots again. So guess what? We had dots here, and we have dots here. This cannot be factored. So I've got x squared plus 9, but I can factor this, x plus 3, x minus 3. And now I can set up for my zero product principle, the ZPP, right? X squared plus 9 is 0, or x plus 3 is 0, or x minus 3 is 0. Here, these are easy. X equals negative 3, x equals positive 3. This one, I'm like, okay, well, x squared equals negative 9. Take the square root. X is plus or minus root negative 9. That's not real, but root 9 is 3. So this is 3i. X equals positive negative 3i. Alright, so I'm just going to make my list of what x equals. X equals negative 3, x equals positive 3, x equals negative 3i, and x equals positive 3i. So if you have questions, post on the discussion. We're asking class. We're in a Google Meet. Google Meet's open every day, all day. Even on a Monday. Alright, so now I want you to pause the video and try to do number 4 on your own, because number 4 is similar to number 1. All right, hopefully you tried this problem on your own. You should have known that you had to make it b equal to 0 first, so take the 20 over. But notice this was a constant term, so you have to combine those two constant terms. You get 9x to the power of 4 minus 9x squared minus 18 equals 0. 9, 9, and 18 are all divisible by 9. There's a GCF here. Take out the GCF. That makes this easier to factor, if it's factorable. This is factorable. It's not quadratic, but it's quadratic in form, and so it factors like a quadratic. Multiplies the 2, subtracts to 1. Well, that's 2 and 1. And so I end up with, in my factored form, 9 times the quantity x squared plus 1 times the quantity x squared minus 2. Now I'm ready to use my ZPP, zero product principle. Well, can 9 ever equal 0? No. This is just a stretch. Remember when we graph these? That's a stretch. Okay, so that's not going to be a 0. X squared plus 1 could be 0. Well, not a real 0 anyway, because, when I solve it, I get plus or minus I. And then over here, x squared minus 2 could be 0 if x is the square root of 2. Positive or negative, right? So I do x squared minus 2 equals 0. Take the 2 over, take the square root. And so I'm going to give my list of answers for x. X equals negative I, positive I, negative root 2, and positive root 2. Oh. There we go. So, if you have questions, please let me know. Please make sure that you're checking homework answers so that you get good feedback and you know what questions to ask. And remember, you can reach out to me in the homework discussion, in class, or in a Google Meet. Have a great day.